Right. Next topic, working of the cell. See, reaction involved will be an indirect redox reaction. Redox reaction means there will be loss of electrons and there will be gain of electrons. In this cell, we are using two metals. One is zinc and the other is copper. You know, metals are electropositive. They have the tendency to lose electrons. But zinc is more electropositive than copper. Means what? It means zinc has higher tendency to lose electrons than copper. Due to this, zinc will preferentially lose electrons, and electrons lost by zinc atoms will move towards copper rod, and copper ions present in the solution will take these electrons and they'll be reduced to copper atoms. It means oxidation of zinc atoms on the zinc rod will take place. Reduction of copper ions present in the solution of copper sulfate that will take place. Now write down. Since zinc is more electropositive than copper, it preferentially loses electrons and gets oxidized. Write down the equation. Zinc gives zinc ions plus 2 electrons. So as you can see, two products are formed. One is zinc ions and 2 electrons. And loss of electrons is oxidation. And since oxidation is taking place in the left vessel, so therefore left vessel will be called oxidation half cell, or we call it anodic half cell, or left half cell. You can call anything. Right on. Since oxidation takes place in the left vessel, it is called oxidation half cell. It is called oxidation half cell or left half cell or anode or anodic half cell. Anodic half cell. Zinc ions formed go into solution while electrons lost move towards copper rod through wires and voltmeter. Look here, two products. Zinc ions will go into solution and electrons will move towards copper rod. See, initially in this vessel, number of zinc ions and number of sulfate ions was equal. It means initially this solution was neutral. But due to the addition of more zinc ions, electroneutrality of this solution will be disturbed because positive ions will increase, negative ions, that is sulfate ions, will remain the same. Now, in order to balance extra positive charge of zinc ions formed, anions, negative ions from the salt bridge will flow out into this solution, and this solution will remain electrically neutral. Right on. Zinc ions formed disturb electroneutrality of the solution but to neutralize them, anions from the salt bridge anions from the salt bridge flow out into the solution. Flow out into the solution. Next paragraph. So that's what is taking place in the left vessel. Electrons coming from zinc rod are gained by copper ions and they get reduced. Write in the equation. Copper ions plus 2 electrons, copper atoms. Since reduction takes place in this vessel, this is called cathodic half cell oblique cathode oblique right half cell oblique cathodic half cell. You should be able to understand from any one of these terms used. Now, in this vessel also, again, there is a problem. Initially, number of copper ions and sulfate ions were equal. Solution was neutral. But due to consumption of these copper ions, positive charge will decrease, but negative sulfate ions will remain the same. Now, how do we compensate for the deficiency of positive ions? For that, cations from the salt bridge will come out and join this solution. That consumption of copper ions disturbs electroneutrality of the solution, due to which cations from the salt bridge flow out into the solution and it remains electrically neutral. It means, if you think carefully, slowly all anions will come out in the left hand vessel, all cations from the salt bridge will come out in the right hand vessel. It means the entire salt will come in these two vessels. Now, what is left in the salt bridge? After some time, only the jelly will be left. And since salt will be exhausted in terms of salt, there will be no salt left. Naturally, salt bridge will stop working after some time and will have to replace salt bridge time to time. Right on, next paragraph. After some time, all the ions of salt bridge flow out into solutions, and the salt bridge becomes dead. It is exhausted. Therefore, it has to be replaced from time to time. Now, once we know the working of the cell, now we know what are the functions of salt bridge. So write down next topic, functions of salt bridge. Functions of salt bridge. Number 1, completes the circuit. When I told you about the construction of electrochemical cell, I told you that so long as that salt bridge was not introduced, there was no deflection in the voltmeter. It means circuit was not complete without salt bridge. Number two, maintains electroneutrality of solutions, which I explained today. Maintains electroneutrality of solutions. Number three, prevents mixing of solutions and thus minimizes junction potential. In short, we can keep solutions in two different vessels. We need not mix them. Last point, reaction can be stopped and restarted at any stage, by removing and reinserting the salt bridge. So at any stage, if I want to stop the reaction, I'll just take out the salt bridge, reaction will stop. After some time, if I want to start the reaction again, I'll put the salt bridge again, reaction will be restarted. Next topic, write down. There'll be very, very small topics. Next topic, reactions involved. Anode, oxidation, cathode, reduction, cell, redox reaction. Although we are supposed to write physical states also, it should be zinc solid gives zinc ions aqueous plus 2 electrons, right? Writing physical state becomes at times important. Second, copper ions, of course, copper ions aqueous plus 2 electrons give copper. This will be copper solid. When we add reduction and oxidation reactions, it becomes redox reaction. So two half reactions when added becomes complete reaction. Complete reaction will be called redox reaction, and this will be this one is a simple case, but in case number of electrons lost and number of electrons gained per particle is different, then you know what you have to do, multiply by suitable numbers so that number of electrons lost and gained becomes equal, and after that add these two equations. Anyways, this becomes zinc plus copper ions gives zinc ions plus copper. Next topic, notations. Notations means symbolic representations. How do we represent cathode, anode, and cell in the form of notation, or you can say symbol? Anode, cathode, cell. Representation of cathode, anode, and cell is based on reactions involved. That's why I've not rubbed them. At cathode and anode, whatever is the reaction involved, look here at the board. Replace this arrow by a slash. Replace arrow by a slash and do not write electrons. That will be the notation of that particular electrode. So anode will be zinc, arrow replaced by slash, zinc ions, electrons are not to be written. As I told you, we should write physical states. Let me write this one this time, solid, and this is aqueous. Similarly, cathode, copper ions aqueous. Electrons are not to be written. Arrow has been replaced by slash, and then copper solid. Now, for notation of the cell, we use two parallel slanting lines at the center. These two lines represent salt bridge. On the left-hand side of these two lines, we write the notation of anode. On the right-hand side, we write notation of cathode. So it becomes zinc solid slash zinc ions aqueous, salt bridge. After salt bridge, copper ions aqueous slash copper solid. So this is the notation of cathode, anode, and the entire cell. Next topic, electrode potential. So this is a value which we'll be using for the calculation of output of the cell. So for that, electrode potential. See, in two vessels, I told you, zinc rod dipped in zinc sulfate solution, copper rod dipped in copper sulfate solution. In general, let us say a metal rod dipped in solution of its salt. Now, I'll go a bit slow so that you can understand. Topic is something normally question is not asked, but it's a part of the syllabus. So when a metal rod is dipped in the solution of its salt, there are two opposing processes which take place. One process is atoms of the metal, they have the tendency to lose electrons and form metal ions. Metal ions will go into solution and electrons will remain in the metal rod, and these electrons will tend to make metal rod negatively charged. Second process which takes place is that metal ions of the salt, they will have the tendency to deposit on the surface of metal rod, and by deposition these metal ions will tend to make metal rod positively charged. So I can say electrons lost will tend to make metal rod negatively charged. Deposition of ions on the surface of metal rod will tend to make it positively charged. Now, depending on relative tendencies of the two, comparative tendencies of the two, this metal rod will be at a negative or positive potential, right? If loss tendency to lose electrons is more, then this will be at a negative potential, right? It will be at a particular potential. Potential difference between metal rod and the electrolyte. Potential difference between metal rod and the electrolyte is called electrode potential, or standard electrode potential, or reduction electrode potential, or we can say reduction electrode potential value, REPV, right? So this is basically the value which we'll be using for calculation. Generally, details are not asked. Right on. But anyways, part of the syllabus, we'll have to do it. Yes, surface of metal electrode acts as boundary of separation between electrode, that is metal electrode, and electrolyte. Metal ions from electrolytic solution have the tendency to deposit on the surface of metal electrode and make it positively charged. Make it positively charged. At the same time, metal atoms of electrode have a tendency to lose electrons and get oxidized. Metal ions formed go into solution while electrons remain in the electrode and tend to make it negatively charged. Depending on relative tendencies of two opposing processes, electrode may be positively or negatively charged
Can you repeat from depending on tendencies?
depending on relative tendencies, comparative tendencies of two opposing processes. Electrode may be positively or negatively charged with respect to the solution. With respect to the solution. Next paragraph. Potential difference between electrode and electrolyte is called electrode potential oblique reduction potential oblique reduction electrode potential value. Reduction electrode potential value. Within brackets, write down REPV. In my assignments, if you find REPV written somewhere, it means we're talking about electrode potential, that is reduction electrode potential value, right? If, now there are three conditions which I'm telling in this next sentence. If concentration of ions is 1 molar, comma, temperature is 25 degrees centigrade, and pressure of the gas, in case any gas is involved, right? Pressure of the gas is 1 atmosphere, then the electrode is standard and its REPV is called standard REPV. So these are three conditions for an electrode to be standard. And if there's deviation in any one or more of these conditions, then electrode will be non-standard. Its electrode potential value will also change. How do we calculate that? That will be the topic which we'll cover in the next class. Next paragraph, rather next topic. Representation of REPVs. Representation of REPV. So if you have to represent the value of reduction electrode potential, how do we represent that? What is the notation? What is the representation? That, for example, REPV of zinc is minus 0.76 volt. I'll repeat, REPV of zinc is minus 0.76 volt, which is represented as follows. Right? Other, you want to ask something? Okay, which is represented as follows. So I've taken the example of zinc. How do we represent REPV of zinc? Write down E0 zinc ions oblique zinc. Now you have to be very careful as far as this representation is concerned. Concentrate on this part. I told you slash is nothing but an arrow. So if you assume that this slash is arrow, it means zinc ions are changing into zinc atoms. When zinc ions change into zinc atoms, this is reduction. It means the value is reduction electrode potential value. This representation is oxidation, zinc atoms changing into zinc ions. In this case, whatever value I write, that value will be oxidation electrode potential value. Relation between reduction and oxidation potential value is only the sign will change. Positive will become negative, negative will become positive. Like REPV of zinc is negative, but its oxidation potential OEPV is positive. And one thing important, for every calculation, you'll be using REPV, you will not be using OEPV. So whenever you have to solve a numerical, first of all, what you have to do is carefully see whether the given value is REPV or not. By chance, if the given value is OEPV, change the sign and then proceed. Look here. Whatever is the value for iodine, if I write E0 I2 oblique I minus some value, this value will be REPV or OEPV?
REPV.
Yes, because neutral particle is changing into negative. If I say Fe plus 3 oblique plus 2, Fe plus 3 oblique Fe plus 2,
REPV.
REPV. Plus 3 changes into plus 2 by gaining one electron, that is reduction. But if I write Fe plus 2 oblique plus 3, that will be oxidation. That will be OEPV. We'll have to change the sign. Good. Next topic. Standard hydrogen electrode. Next topic, standard hydrogen electrode within brackets SHE oblique. There's one more name for this, normal hydrogen electrode, normal hydrogen electrode within brackets NHE, NHE. Draw a rough diagram. Diagrams are not important in chemistry. Draw a rough diagram. This is platinum electrode which is sealed in a glass tube. That will dictate you. This solution is 1 molar H plus ions at 25 degrees centigrade. Temperature 25, standard. Concentration of ions 1 molar, second standard condition. Third is hydrogen gas at 1 atm pressure. That is third standard condition. Right on. It consists of a platinum electrode sealed in a glass tube, which has a side tube through which pure hydrogen gas at 1 atm pressure is passed and bubbled through 1 molar solution of H plus ions at 25 degrees centigrade. In one sentence, everything has come at 25 degrees centigrade. But remember one thing, concentration of H plus ions should be 1 molar. I didn't say that the concentration of acid should be 1 molar, because if it is sulfuric acid, then sulfuric acid should be 0.5 molar. If it is 0.5 molar sulfuric acid, naturally concentration of H plus ions will be double, that is 1 molar. If it is HCl, 1 molar HCl will be 1 molar H plus ions. So that you have to keep in mind. Continue. Standard REPV of SHE is assigned, I'm not saying is equal to, is assigned equal to 0 volt and represented as E0 platinum oblique H plus oblique H2. Now there's something interesting. You should look at this notation carefully. Basically, H plus ions are changing into H2. This is reduction, and that's why this is REPV. But why have I written platinum? Remember, it's not only in this case, in general also, I'm telling you one thing. Out of these two, if none of the two is solid, remember, solid reaction will always take place on the solid surface. If none of these two is a solid, then on the extreme left, we write platinum, and this platinum is nothing but it's an inert electrode which is used to provide surface for the reaction to take place. Platinum will not take part in the reaction. It will just provide surface for the reaction to take place. Similarly, in the notation for the cell, in the anode, if there is no solid, then on the extreme left, platinum. If there's no solid in the cathode, then on the extreme right, you'll write / platinum, right? That is just to provide surface for the reaction to take place. Now, SHE is assigned RePV, and in comparison to standard hydrogen electrode, any other electrode is assigned RePV. How is that comparison done? How is that calculated or experimentally determined? Very small topic. Write on heading: how to assign RePV to the given electrode. How to assign RePV to the given electrode. That given electrode is connected to SHE by using wires, voltmeter, and salt bridge. Output of the cell is determined from the voltmeter. Now, write on A part. If oxidation takes place at SHE, then E0 electrode, it means standard RePV of the given electrode, is equal to E0 cell B. If reduction takes place at SHE, then E0 electrode is equal to minus E0 cell. Now this I'll explain, for which I need the next topic. So first I'll take up the next very small topic, and then I'll explain what's the meaning of same value or minus value. I'll explain that. Right, next topic, cell potential. That is, how do we calculate output of the cell? That is called EMF of the cell. If you remember, you might have done in 11th standard, that is E0 right minus left. Same formula. Right. In a galvanic cell, anode is at a negative potential. Why it is at a negative potential? Because electrons are lost at anode. Negative potential, while cathode is at a positive potential, due to which electrons flow from anode towards cathode and current in the opposite direction. Potential difference between two electrodes is called cell potential or EMF or cell voltage, which is calculated as follows. Simple formula. E cell. If it is a standard cell, we can write E0 cell, right? Is equal to E0 cathode minus E0 anode. Cathode is the right half cell, anode is the left half cell, or therefore we can also say E0 right minus E0 left. Easiest way is E0 R minus E0 L. What are E0 right, E0 left? For that, we took up the topic electrode potential. So electrode potential values will be given except the electrode potential value of hydrogen, which everyone knows its value is 0. So depending on whether the reduction takes place on a particular electrode or oxidation, you have to properly use those values. Just subtract and you'll get the answer. Now I'm explaining the previous topic. How do we assign REPV to the given electrode? Look here. I think from the diagram it's clear. This shows this is standard hydrogen electrode, G for given electrode. And I want to assign REPV to this given electrode. So I've connected given electrode with SHE by using wire voltmeter and salt bridge. From the voltmeter, I'll directly read the value of E0 cell. Just now I told you E0 cell will be equal to E0 right minus E0 left. Right. Which half cell is right? Right half cell is the one in which reduction takes place. Remember, right, like this, RR, right reduction, as simple as that. So reduction takes place on the right half cell. Now there are two possibilities. When we connect the given electrode to SHE, either reduction will take place at SHE or oxidation will take place at SHE. Naturally, the other process will take place at the given electrode. Look here. If oxidation takes place at SHE, it means SHE will be left half cell. It means this value will be 0. And if this value will be 0, then E0 cell, which we directly read from here, that will be equal to E0 of the given electrode. Second possibility, if reduction takes place at SHE, it means SHE will be the right half cell, cathode. In that case, value for the right half cell will be 0. Then what is the value of given electrode? It will be minus E0 cell. So that's what was the meaning. Now, I'm sharing one very simple numerical, very, very simple, and we'll solve it. Check your WhatsApp message. It's very simple. Calculate E0 cell of the cell in which reaction involved is so and so. E0 aluminium is minus 1.66. E0 copper is 0.34. Now, first of all, what you have to do is carefully see whether given values are REPVs or not. Let me tell you, both the values as per notation, both the values are reduction potentials. None of them is oxidation potential. Now, according to the equation, which reactant is oxidized? Copper is oxidized, aluminium is reduced. It means the value of the cell will be E0 copper minus aluminium. So E0 cell will be value for copper 0.34 minus of minus 1.66. That is the value for aluminium. So this will be 2 volt. Next topic. Now very, very simple, maximum 5 more minutes. Next, electrochemical series. Electrochemical series. See, this is something, if you remember, in 10th standard, you might have come across a topic in metals, activity series of metals. The same activity series which was without any value is with values in 11th and 12th standard, and that is called electrochemical series. And this includes metals and non-metals both. It is a vertical series. It is, we write it vertically. It is a vertical series in which various redox couples. I told you redox couple, right? Well, when I talked about construction of the cell. Various redox couples are arranged in their decreasing REPVs. Decreasing REPVs means redox couple with a higher positive value on the top, then lower positive, lower positive, lower positive, then zero. After zero comes negative, then higher negative and higher negative. So as we move down the series, value of REPV will keep on decreasing. Right on. Down the series, write down 6 points. As we move down the series, what will happen? Number 1, REPV decreases. REPV decreases. Next will be opposite. Number 2, OEPV increases. OEPV, oxidation electropotential value, will increase. Number 3, reducing power will decrease. Sorry, reducing power increases. Next, oxidizing power decreases. Now, why it is so? See, as we move down the series, I told you, REPV decreases. Remember, if REPV is high, tendency to gain electrons is high. If REPV is low, it means tendency to gain electrons is low, but tendency to lose electrons is high. All those which have a negative value, they have higher and higher tendency to lose electrons, right? So as we move down the series, negative value will increase, means tendency to lose electrons will increase. Those which lose electron, they reduce others. So I can say reducing power increases, but oxidizing power decreases. Next, number 5, tendency to lose electrons increases. Last, opposite, tendency to gain electrons. Tendency to gain electrons decreases. Next paragraph. Any two electrodes any two electrodes of the series can be combined together. When I say combined together, naturally, combination means by using wire, voltmeter, and sort bridge. I'll repeat, any two electrodes of the series can be combined together to construct a cell out of which electrode means redox couple of higher REPV will be cathode. So if there are two electrodes given and we combine them to construct the cell, which of the two will be cathode or anode? It's very simple. I said the one whose value is higher will be cathode. And it's understood the other will be anode. Continue same sentence because E0Cell is always positive. E0Cell cannot be negative. E0Cell is always positive. So the last one numerical, then we wind up. This is in text numerical number 7. We'll solve this one. Check your WhatsApp message. Give cell notation, cell reaction, and calculate E0Cell of the cell whose electrode potentials are this and this. First of all, look at these values carefully. What do you think? Do you need to change any one of these two values? Do you need to change any one values? Oh, first value needs to be changed. This value will be E0 chromium ions oblique chromium, and this will become minus 0.74 volt. Second value is correct for aluminium, minus 1.66. Naturally, out of these two, the one whose value is higher, this value will be higher. This will be cathode. Cathode means this will be reduced. So we have to give cell reaction. For cell reaction, aluminium atoms will be oxidized. Chromium ions will be reduced. Add aluminium plus chromium ions, give aluminium ions plus chromium. This is one answer, that is cell reaction. Second, we have to write cell notation. Salt bridge at the center, anode on the left, aluminium oblique aluminium ions. Cathode on the right, this will be chromium ions oblique chromium. This is the second answer, that is notation. Third, we have to calculate E0Cell. Will be right minus left. Right is minus 0.74 minus of minus 1.66. This will be 0.92 volt. Right. That's all for today.